Hey students, this is Mrs. Tran-Bloom. Well, welcome to section 3.1, guys. So this section, we will be studying how to graph your quadratic functions. Now, for this particular section, we will only be studying the standard form and the intercept form, okay? But before we dive right into that, let's review some skills that we have already studied in Unit 1. So the review says, graph and answer the characteristics requested for the following functions. Write NA if it is not applicable. So if you need some more review, please go and look at your Unit 1 note outlines. So the first one we have here is a linear equation. 3x minus 4y equals 12. Now guys, this is what we call the standard form, okay? So standard form of your linear. So there are multiple ways to graph this. There's no wrong way or right way. It's whatever you're more comfortable with. Some methods, it's easier than others, but again, you will always get the same answer. So the first one I'm going to do is I'm going to find, in standard form, my go-to is always looking for the x and a y intercept. X intercept, students, is when the y equals to 0. So I'm going to go 3x minus 4 times 0 equals 12. And as you can see, when it's in standard form, it's so easy, right? Because 0 times anything is 0. So now we just have 3x equals 12. Divide both sides by 3, so x equals 4. So here's our x-intercept. And remember, x and y-intercept, we want to write it as an ordered pair. So 4, 0. And also, let's fill in the characteristic box over here. We're just going to say x-intercept, so 4, 0. Now we want to do the y-intercept, very similar. Y-intercept is when x equals to 0. So 3 times 0 minus 4y equals 12, and that goes away. So now we're just going to divide both sides by negative 4, okay? So y. Y is going to come out to be negative 3. And again, remember when we write it as an order pair, we're going to write 0, negative 3, and that's your y-intercept. So that's going to be right there, and fill that in since we have it next to each other. And I'm going to use a straight line. Linear means it's a line, so connect your two dots and make a line. Now, another way that some of you, from what I remember during Unit 1, whoa, that's a nasty little, not a very straight line. I do have a ruler. Whoa, I didn't remember this, but now I remember. Okay, so I remember some of you said, well, could I just go and solve for y and then graph it that way? Of course you can, okay? So let me show you how some of you guys would do this. So minus 3x from both sides because you want to solve for y. So this is negative 4y equals negative 3x plus 12. Then divide each and every term by negative 4, students. Okay, this allows you to say y equals negative 3 divided by negative 4 is positive 3 over 4, and then drop down your x. 12 divided by negative 4 is going to be a negative 3. So here's your y equals mx plus b. And you would do the same way. You could plot a negative 3, and then you go up 1, 2, 3, to the right 1, 2, 3, 4, and guess what? You get the same two dots, so it doesn't really matter. Now, the linear doesn't have a vertex. Remember, the vertex is either the highest or lowest point, okay? And since a line does not have a highest or lowest point, our direction says right NA. It does not have an axis of symmetry. Remember, axis of symmetry is a line that divides the left and right perfectly. This is symmetry, okay? We already did the, whoops. You know what? I meant to put those in the right places, but clearly I was one. Okay, so your x-intercept was 4, 0. Your y-intercept was 0, negative 3. The line doesn't have opens up or down, so again, we're going to write NA. The domain, if you guys remember, it's all real numbers. Now, sometimes if it's a multiple choice, we could also write it as an interval notation, so negative infinity to infinity. The range is also all real from negative infinity to infinity. You can write both of them on your note outlines. Now, when you're doing your homework, you don't have to write both, but I just want to give you a warning. If it's an exam, we could pick either as a multiple choice, okay? It's definitely a function. Now, you guys remember, it's a 1-to-1 if it passes a horizontal line test. So we could make any horizontal line we want, and it should only intersect it no more than once. So in this case, it is a yes. A rate of change is fancy for slope. And then look, ooh, the slope is going to be 3 over 4. Ooh, let me make this a little bit thinner. Okay, so 3/4. It is an increasing interval. So it's going to increase the entire domain, which is from negative infinity to infinity. We're going to write NA on decreasing since all of the values on the domain is for increasing. Now, it does not have a minimum or maximum, so we're going to write NA, or you can even write none if you want, okay? All right, is it continuous? Yes, remember continuous is when you can graph the entire line without lifting up your pencil. So that's how we graph a line from unit 1. Now, an absolute value function, students, is when you make a V shape. Remember this? And remember, it's in the form y equals a times the absolute value x minus h plus k, where your vertex is h comma k. And just to kind of review as well, if a is positive, okay, it opens up. Okay, if a is negative, let's give this a space. A is negative, it opens downward. So simply, we can just see by our way. Okay, so a is oh, why are these pens so fat? Okay, a is negative 1 over 2. A is in the front. H is going to be positive 3, opposite of that, okay? And then K is going to be 1. So immediately we can find a few things. H comma K is your vertex, so that's going to be 3 comma 1 right here. Axis is symmetry, so we can plot that right away. So 3 up 1. Okay, your axis symmetry is a line that's going to divide your V shape in half. So it happened to be the same exact location, which is going to be your value of 3. But it's a line, so we write x equals to 3. Opens up or down. Since A is negative, we're going to say it's going to open downward, okay? We don't know an x and y intercept yet since we have not graphed it out, but we can totally graph it right now. So remember, an A value of negative 1/2, it's also the slope, right? Remember, it's a V shape, so we know the slope is either negative 1/2 and positive 1/2. So if it's a positive 1/2, we can go down, okay, down and then left. That will make a positive. Down means 1 and left means 2. And it's symmetrical on both sides. So what happens is you want to do exactly the same, but the other side. So down and right, because that will make down, that means negative 1. Right is positive 2. And then take a ruler, guys. No freestyle, because these are supposed to be nice 2 straight lines. Okay. There you go. Do this side. And then make your arrows. So now it looks like a V. So as you can see, we have 2 x-intercept, and we can pinpoint that right here without doing any work. X-intercept is when it crosses the x-axis. So it's going to be 1, 0, and then 5, 0. There are 2 of them. Y-intercept is not something that we can pinpoint perfectly, so we will need to do some work there. The domain, students, is all real numbers, or from negative infinity to infinity. The range looks like it's going downward, but the largest y value you do have is 1. So y is less than or equal to 1. Or interval notation is negative infinity to 1, and then a bracket because it is inclusive. It is definitely a function, okay? Remember, a 1-to-1 means, does it pass the horizontal line test? And when we make a horizontal line test, it crosses 2 times. So no, it is not a 1-to-1. So I'm going to erase that. A rate of change means there's a slope, so there are 2 of them, okay? So plus or minus 1 over 2, or you can write 1 over 2, comma, negative 1 over 2, like that, 2 separately. Increasing interval, remember, increasing is when you're hiking up. Oh, this is so hard. So that's going to be on the left side of your axis symmetry. So it's going to be a negative infinity, and we only use x. Remember, this is a 3, so x is at 3, so we're going to go comma 3, and then we can use a bracket or parentheses here. Decreasing is when you slide down, whee, right? So it's going to be 3 to infinity. Remember, increase and decrease, we only use x values. Since we have a vertex and it's opening downward, meaning that we will have a maximum, and the y value is the only one that we would use, and maximum is 1. Okay, and it's definitely continuous because we can graph the entire V shape without doing any work. The only thing left we need to do is to find the y-intercept. And again, y-intercept is when x equals to 0. So y-int. So x is 0, y equals 1 over 2 negative. Let me write that again. Y equals negative 1 over 2. Okay, every time you see an x, plug in a 0. Okay, close it back up and then plus 1. 0 minus 3, students, is negative 3. Okay, but an absolute value of negative 3 is going to be a 3. Okay, so that's going to come out to be a negative 1/2 times 3 plus 1. Well, negative half times 3 is negative 3 over 2 plus 1. A negative 3 over 2, students, we convert that out to negative 1.5 if you really wanted to. No, you don't have to do that step. But as you can see, we're going to end up with a negative 1 over 2 for your y-intercept. But we need to write it, and it makes sense. Look, it's a negative 1 somewhere there. So write it as an ordered pair. 0, negative 0.5 or negative 1 over 2. Okay, our third review, students, it's a piecewise, and we can see that there are 3 pieces, right? So piece number 1, what's going on? Piece number 1, piece number 2, and the third piece. And if you guys remember this one, it says, okay, piece number 1 is 3x when x is less than negative 1. Remember, x is less than negative 1, it means it's an open circle and it goes left. Piece number 2, y is always 4 when x is in the middle of negative 1 and 5. Now, negative 1, can you see there's no equal right there? So that means it's going to be an open circle. And so this is what we call a segment, right? A segment is when it starts and it ends. And then the third piece is going to be negative 1/2 x plus 1 when x is bigger than 5. So as you can see, bigger than 5 means the third piece is a right and it goes to the right. So I'm going to do, now there are, again, multiple ways to go about this, but I normally graph it using a table. So I'm going to start with the negative 1 for my x value. Oh, that does not look like an x. Okay, an x value and a y value. Start with negative 1. And I would like to pick 2 more values that fits this restriction constraint. So numbers that are less than negative 1, the next nice one is negative 2 and negative 3. And then we plug it in to get your y. So 3 times negative 1. So 3 times negative 1 is going to be negative 3. 3 times negative 2 is going to be negative 6. 3 times negative 3 is going to be negative 9. And 3 points will make a nice little straight line. So the first dot's negative 1 down 3, open circle, and then negative 2, and then going to 6. Now, another way is just going to look at the slope, guys. If the slope is 3, then you can have 3 over 1, that's a positive 3, or negative 3 over negative 1. So negative 3 means down 3, 1, 2, 3, and then left 1. So as you can see, it will give us the same exact location. Okay, so here we go. Piece number 1, nice straight line. Use your ID if you have it. A ruler, it's good too. And then make your arrow. Piece number 2, I will use this line right here. Remember, your chart is just going to be super simple. It's going to start piece 2, P2. You're going to start with the first value that they give you and the last value, negative 1 and 5. Now pick one in the middle. So 0 will be a nice middle value. And doesn't matter, students, because whatever x is, y doesn't have a variable. So y is always going to be 4. So that's what's happening here. So negative 1, go up 4, so open circle, 0, 4, and then 5, also 4. Make a nice straight line. This one is just going to be flat because y does not change. Y doesn't have a variable. So it's always going to be a flat line, constant. Third piece, ready? Piece number 3. Remember, you always want to pick the first value of x that you see. So in this case, it's 5. So we can plug it in. It's going to be negative 1 over 2. Let me make this bigger. So negative 1 over 2, and then looks like we have times x, so x is 5, and then it's going to be plus 1. Well, negative 1 over 2, students, times 5 is going to be negative 2.5. Negative 2.5 plus 1 is a negative 1.5, or negative 1.5. Now we do want to pick 2 more values to make it a better straight line. So since the denominator is 2, I would like to pick 6 and 8 because even numbers, when you multiply by half, is really friendly. So negative 1/2 times 6 plus 1. So negative half of 6 is negative 3 plus 1 is negative 2. And then negative 1/2, okay, times 8 plus 1. Again, negative half of 8 is negative 4 plus 1 is negative 3. And we can pick more values in theory, but those are good enough to graph. So at 5, I'm going to go down negative 1.5. Remember, it's an, ooh, you know what I just missed? Close dot, my bad. Okay, needs to be close, okay? All right, over here, I'm going to go open circle at negative 1.5. And then 6, close dot at negative 2, and then 8 is going to be negative 3. And we can keep on going if you want. So, but 3 points is plenty to make a nice straight line. Okay, so there it is. Let's answer all the characteristics. We don't have a vertex here, students, so we are going to say NA. Remember, the vertex is when you have the highest like location, one location, okay? Axis of symmetry, we don't have any since left and right, we can't really make it perfectly symmetrical. It's not a V shape, so right now it's neither open downward or upward because it's these are lines. X-intercept, we can see that none of these pieces are crossing over the x-intercept. Y-intercept, we do have one. It is going to be 0, 4. The domain is going to be, it appears that it's all real numbers except, look at this, guys, except here is where both of them are open. So that means there's no x value at negative 1. So we have to write this very cautiously, okay? It's going to be negative infinity to negative 1. Take a little break. And then remember, union, it's, remember connecting these two pieces, okay? So negative infinity to negative 1, union, negative 1 all the way to infinity. Now, I'm okay too, students, if you don't write the union and just do a comma like that. I'm okay with either, okay? Your range value, it looks like, okay, negative y, that means all the way value here. But look, at negative 1.5 is the highest for that piece. And then there's nothing here. So that means we're going to union that again, okay? So negative infinity, comma, remember the highest for the green piece is negative 1.5, and then nothing in the middle until the red segment. So union or comma, you can just write 4, okay? Something like that's fine. Or you just say, hey, you know what? Can I use a comma? Yes, you can, like that. Is it a function? Yes, it is, okay? So a function is when you make a vertical line test and it's only going to cross twice. Okay, so now some of you said, well, if I make it here, doesn't that cross over twice? No, this open circle right here, meaning that it's not even there. So that's why the open circle technically doesn't really count, okay? Is it a one-to-one? Well, let's make a line really quickly. Nope. Okay, it crosses over the blue and the green, so definitely not a one-to-one. The rate of change looks like we have 3 pieces, so we're going to have 3. So the first one's 3. This right here, students, has a slope of 0, okay? So that's going to be 3 and then 0 because you have this horizontal line. And then the next one is negative 1/2. We have an increasing, it's going to be the blue one. So here's going to be from negative infinity. This x value is negative 1. So increasing from negative infinity to negative 1. Decreasing is this green one. It starts here at 5 and it goes x indefinitely to the right. So 5 to infinity. Okay, so decreasing 5 to infinity. We have the highest value, and this highest value happens to be a constant line. So the y value, it's always going to be 4. So it happened to be, oops, maximum, guys, because that's the highest. We don't have any minimum value since the arrows for both the blue and the green are going downward forever. It is definitely not continuous since we have to lift up our pencil to graph all 3 pieces. Since Unit 3, students, is all about graphing, okay, we're kind of picking up from Unit 1. So Unit 3.1, we will study quadratic functions, okay? Just like the 3 forms of linear equations, each different form of the quadratic shows us a different feature. That means something important. we can use the feature to assist us in graphing. The vertex is generally the most important point. So knowing how to find it is a useful or necessary skill. Okay, let's start with the 3 forms. The first one's called the vertex form, which students, we will study this in the next section. So this part of the notes, we will be studying the standard form and the intercept form. So the standard form is always f of x equals ax squared plus bx plus c. Remember, f of x is the same as y. Intercept form, students, really important that you also write down this. Sometimes we call this the factor form, okay? Because if you hear me, oh, factor form or intercept form, they are exactly the same. Now, intercept form is y equals a times the quantity of x minus root 1, okay? And then times the quantity of x minus root 2. Now, each form gives us unique features, right? So the standard form is going to give us something super fast, which is the y-intercept. Because y-intercept is when x equals to 0. I mean, this is gone and this is gone. So that means we can find the y-intercept super fast, which is 0, c. Now, the intercept form, students, aka factor form, will show us the x-intercept super fast. I know, right? Remember, x-intercepts when y equals to 0, and since it's already factor, we will have 2 for this one. Sometimes we'll have 1, and sometimes we'll have none. But for this one, if we take each one and set it equals to 0, right? Then that means the first root, we'll use r here for root. The first root is really root r1, 0. That's your first intercept. Then the second intercept is r2, 0. These are super important. Now, all quadratic functions will have a vertex, just like your V shape, okay? In standard form, to find the vertex, and again, the vertex, just like the V shape, it's always h, k. Now, first, you're going to find the h value, and the h value is going to be a negative b divided by 2 times a. That's how you find the x coordinate. Okay, so this is x coordinate of vertex. Now, step number 2, to get the k value, which is aka y coordinate of vertex, you will need to plug h back into the original equation. Okay, that's how you're going to find your vertex. Now, when it is in the factor form, to find the h, k, aka the vertex, step number 1, plot x-intercepts. Okay. Step number 2, find the middle. Find the middle. This will gives h value. The middle is going to give you the h value. Then step number 3, plug h value in to the equation. It's writing funky because it's too stretched out. To obtain k value. What do you say that we put this to work? Okay. All right, here we go. Let's start with the very basic one. Graph and state the characteristics of the equation y equals x squared. The reason we know it's a quadratic because it's a power of 2. So this is more important. When you don't see any a, h, or k value, that's not 0, 1 here. This is called the parent function. Okay, parent function. So, and let's start with what we know, right? So a, remember, The normal equation, students, the standard form is always going to be y equals ax squared plus bx plus c. Well, we don't have this. We don't have this. And then if you don't see a number in the front, it's always 1. So a is 1, b is 0, and c is 0. So right away, okay, we can make a chart. So easiest is going to be values that we can plug it in our head, right? So 5 values. I would like for you to pick 5 values for your quadratic formula here. So when x is -2, it's a -2 quantity square. So that's going to be 4. When x is -1, we're plugging it back to here. When x is -1 quantity square is going to be 1. 0 square is 0. 1 square is 1, and 2 square is 4. So -2 up 4, and -1 up 1, 0 is 0, back to 1 comma 1, and then 2 comma 4. As you can see, it's not a V, it's a nice round out about here, so don't make this into a V. So all quadratic function, students, it's going to give us a U shape, okay? So all quadratic function will give us U shape. Okay, let's fill out some information. Your vertex, since this is your vertex, is at 0, 0. It's this little guy right here at the origin. You do have an axis of symmetry. Remember, an axis of symmetry is when you divide it evenly on left and right. So it's going to be at x equals to 0. It opens upward, okay? Since a is positive, x-intercept, x and y happen to be the same exact spot, so they're both at the vertex. The domain is going to be all real numbers, or in the interval notation from -infinity to infinity. The range, students, it looks like it goes up, so that means L value bigger than or equal to 0, or interval notation, bracket 0 to infinity. Is it a function? Yes, it is. Now, is it a one-to-one? That's even more important. If we make a horizontal line test, it crosses twice, so no, not a one-to-one. The rate of change. So now let's talk about the rate of change really quickly. Now, earlier, we reviewed some things from Unit 1. And in Unit 1, we studied lines, okay? So lines have the slope, aka a fixed rate of change, okay? Now, anything that's not a line, in the future math classes, students, you will be able to find the rate of change. But in our class this year, we're going to say it varies. It's not the fact that it doesn't have any, it varies. Increasing is going to be, remember, when you're hiking is when you increase, right? So on the right side, this is going to be a steep hike, right? Remember, hiking is, you're going to go from left to right. So on the right side, you're increasing. So that's going to be x at 0 and all the way to infinity. On the left side, when you're going to be sliding down, and it stops at the minimum or maximum. So it's going to be from -infinity to 0. Now we have in the vertex, which is the lowest point, so that's a minimum. In this case, it's 0. Only the y value here, okay? And then, yes, it is continuous, since we can graph the entire U shape without lifting up our pencil. Example 2, guys, says f of x equals 3x squared plus 12x plus 10. So as you can see, this is definitely in standard form, right, guys? Your a value is 3, your b value is 12, and c is 10. Now, since a is positive, we know it opens up. Some of the things we can find without doing any work, right? Now, first is to find the vertex, and a vertex is an ordered pair, is a point. Let's go up to your notes. Remember, learning how to read your notes is really important. To find the vertex, right, in standard form, this is what we want to read. First, h equals -b divided by 2a. So students, highlight this, okay? Tell yourself to know it. This is the x coordinate of the vertex, since the vertex is a point. Now, 2, k, aka the y-coordinate of the vertex, is to plug h back into the original equation. So let's do exactly that. So let's find the x-coordinate of the vertex, which is x equals negative b all over 2a. This is the same as the h value, right, guys? Okay, so x equals negative b, b is 12, negative 12, divided by 2 times a is 3. So that's going to be negative 12 divided by 6. That's going to be a negative 2. To get the k value, we plug in negative 2 back into the original. So that's going to be y equals 3 times, every time we see a x, we plug in negative 2 and a square. One x location, 2 x locations, okay? Plus 12 times negative 2 and drop down your positive 10. So that's going to say plus 10. So this is going to say 3 times 4 minus 24 plus 10. This is going to say 12 minus 24 plus 10. This is going to say, okay, well, 12 minus 24, guys, is going to be negative 12 plus 10 is going to be negative 2. So the h and k value, okay, h value, they happen to be the same here. Not all the time. I just want to warn you guys, okay? So negative 2, comma 2. That looks like, there you go. Axis of symmetry. Remember, let's plug that in. Negative 2, negative 2, negative 2. Okay, negative 2, negative 2. We know it opens up. Axis of symmetry is exactly in the middle. Okay, we know it opens upward. So all we have to do, remember, it's a U shape, so it should look like this. So that means the left and the right should be exactly the same. What you want to do is, since your h comma k, negative 2, negative 2, we want to pick 2 more values, whether it's on the left or right side of your vertex. It doesn't matter. I always go and pick values that are closer to the zeros here. So it's easy. So the next one I'm going to pick on the right side of my vertex is negative 1 and plug it in. So it's going to be 3 times negative 1 quantity square plus 12 times negative 1 plus 10. So 3 times negative 1 quantity square is going to be 3 minus 12 plus 10. 3 minus 12, guys, is going to be a negative 9. Negative 9 plus 10 is going to be a positive 1. So y is going to be a positive 1 when x is negative 1. So let's go and plot that. Okay, negative 1 up 1. Okay, next I'm going to pick 0. Notice how I'm only going to pick values that are easy for me to do in my head. So, well, when x is 0, this is gone, so that's going to give us 10, okay? And that happened to be the y-intercept, so let's fill that in too, because x is 0, y is 10. Look at that. There you go. So now, because it is a U shape, the left side will be exactly the same, just reflected over that axis of symmetry, just like that. And what you want to do, students, is round out the base so it doesn't look like a V, so like this. Okay, and then connect it to that next dot, which is up there. I know by hand it's a little bit more difficult, so this should look like this. Now, if it happens to look like a U, fix it. You cannot look like a U. So x-intercept, we would need to do some work to figure out what that is. Your domain is going to be all real numbers. Now, sometimes you can also state negative infinity to infinity if that's your preference. It opens upward, but the smallest y value is going to be a negative 2. So y is bigger than or equal to negative 2, or bracket at negative 2 and then up towards infinity. It's always going to be a function for all quadratic formulas. It is not a one-to-one because remember, it does not pass a horizontal line test. The rate of change for all quadratic functions, we are going to say it varies. It does have an increasing and decreasing interval. Increasing is going to be on the right side of your axis of symmetry because this is the side that we hike up. Oh, so hard, right? So that's going to be hiking. So that's going to be x value first, small x value first. So negative 2, because this is a negative 2 on the the line here. And then it's going to be to the right side. That's going to be infinity. And then the means decreasing is when we can slide down, wee, right? So it's going to be a negative infinity, comma, negative 2. Your vertex is going to be a lowest point, so that's a minimum. And that y value right here is going to be a negative 2 and is definitely continuous. And pinch that in. Now, last part is x-intercept. We need a little bit more math, okay? X-intercept, students, is when y equals to 0. So 0 equals, it was positive 3x squared plus 12x plus 10. Remember, you guys already know how to solve the quadratic equation. So there are 3 ways. Completing the square. Well, we don't want to complete the square because a is 3, not 1. Number 2 is see if it's factorable, and then number 3 is the quadratic formula. To see if it's factorable, we're going to say, okay, well, find 2 numbers, multiply equals 30, and add equals 12. So we got 3 and 10, not really good. 5 and 6, not really good. 2 and going to be 15. Neither of those choices, none of those choices is going to add up equal to 12. So not possible to factor. So we're going to do the quadratic formula. X equals negative b, which is negative 12, plus or minus square root b squared, 12 squared, minus 4 times 3 times 10 all over 2 times 3. So that's going to give us negative 12 plus or minus, students, 144 minus 3 times 4 times 10. That's going to be 120 all over 6. Okay. Now, if we look at your 144 minus 20, what you want to do is do that first, which is plus or minus square root of 24 all over 6. And yes, we need to simplify the square root of 24. So x equals negative 12 plus or minus square root 24 is 4 times 6, because we know square root of 4 is going to be 2. X equals negative 12 plus or minus, students. Square root of 4 is 2. Square root of 6 is not possible to make it nice, so leave it on the inside. Now we need to simplify because each and every one of these outside numbers, students, it's even. That means they are divisible by 2. Yes. Okay. So it's going to be x equals negative 6 plus or minus, you can say 1 rad 6, which is simply rad 6 all over 3. So here are the 2 x-intercepts. Sometimes we make a list if we really wanted to, like this, right? All over 3, comma, negative 6 minus rad 6 all over 3. Those are the x-intercept, but we have to write it back with order pairs. So you can do a plus or minus, or you can just keep it as a list. So negative 6. I'm going to do a plus or minus rad 6 all over, was it 2 or 3? 3. So erase the 2. And I think I need to put the 10 back since I accidentally deleted that, comma, 0. And that's going to be your 2 x-intercepts. Example 3 says y equals negative, and then quantity x minus 5 times quantity x minus 1. Now guys, if you see a negative and there's no number, you can always put a 1 here if you want. Remember, this is the factor form. And then remember, factor form is also called the intercept form. So the easiest, students, is really to find the x-intercepts. X-intercept, we want to take y and set it equal to 0, negative 1 times x minus 5 times x minus 1. And we are going to take each factor, just like unit 2, to solve for this. Take each factor and set it equal to 0. 0 equals negative 1, not really likely. X minus 5 equals negative 1. I'm sorry, x minus 5 equals 0. And then x minus 1 equals 0. So that means x is at 5 and at 1. So we have 2 x-intercepts, okay? 5, comma, 0, and then 1, comma, 0. Remember, in your notes, it says, okay, well, go and let's go look at your notes. to read over what we need to do. Remember, notes are important for you, right? So in the factor form, right here, okay, it shows the x-intercept immediately, okay? To find the vertex, step number 1, plot the x-intercept. Step number 2, find the middle, which gives us the h value. And then step number 3, plug in the h value to get your k value. And let's go do that. All right, so we plot it. Let's plot it. 5 and 1. Here's 5. Here's 1. Oh, what's going on with my dots? Why is it not plotting correctly? Maybe I'm too zoomed in, so let's do that again. So 5, there you go, and then 1. Now let's draw the middle, which is the axis of symmetry, which happened to be at x equals to 3. Fill that in. X equals to 3. That means your h value, guys, is 3. So let's plug it in to get your k value. Vertex, okay. We have h equals 3, which because that's the middle, y equals -1 in the front, h is the same as x, okay guys? So that's going to be 3 minus 5 times 3 minus 1. So this can be -1 times -2 times 2. So this will give us a positive 4. So your vertex is 3, 4, just like that. Now the a value is right here, students, okay? A is -1. So since it's a -1 right there, we will going to have a U shape opening downward. So let's plot your vertex at 3 up 4. And look, no work needed. We have 3 dots. Connect it, round out the top here. There's your U shape. Let's fill out what we can. Y-intercept, we don't know. We have to do some work. So y int when x equals to 0. So let's do that. Y equals -1. 0 minus 5 times 0 minus 1. -1 times -5 times -1. So that's going to be a 5 times -1, which is -5. So y-intercept is going to be 0, -5. Let's plot that. Now, if I were to plot this first before I graphed it, that kind of should be a little bit better. And remember, it's mirror image, right? So the other side should be exactly the same. 3 units out at the same exact y location. Just like that. Much better. All right. What else can we find? Oh, why did I open? 0, -5 opens down. Okay. The domain is always all real. The range is going to be y is going to be less than or equal to 4 or -infinity up 4 and then bracket. Is it a function? Yes, it is. It is never a function. It's never a one-to-one. So no, the rate of change we are going to write varies. Increasing, remember increase is when you hike up. So we're hiking up on the right side here. Okay. Oh, that's hard work. All right. So that's going to be from -infinity. Your x value is at 3. So stopping at 3. Decreasing is when you go sliding down. So 3 to infinity. It is going to be a maximum since it is now on the top, and the y value of that is 4. Okay, and it's always going to be continuous. And looks like we have a graph and we fill in all of the charts. Okay, guys, so now I would like for you to take a few minutes to write down some strategies for yourself. Okay, what are some strategies you should use when you're graphing the quadratic function given in standard form or ones in intercept form? Now, the last piece that I would like for you to do on your own would be this right here. So this is the one that we're going to be checking for your understanding. Check yours, okay? Your understanding. Now, if you need to, can you please read your example number 2 again to see what you need to do to complete this. Once it's done, feel free to check back for the right answers.